today's lesson, we're going to be talking again about displacement and distance traveled. So again, in the context of position, velocity, acceleration. We've seen this several times throughout the year. So let's just remind ourselves of the relationships we know already. We know that if S of t is position, then its derivative is velocity, and its second derivative is acceleration. We also know some things about language connections with position, velocity, acceleration situations. We know that an object is stopped when velocity equals 0. We know that the object is moving left when velocity is negative, right when velocity is positive. We know it's speeding up if velocity and acceleration have the same sign. And we know it's slowing down if velocity and acceleration have the opposite signs. Today we're going to look at a situation where we know something about the velocity and we're trying to talk about position and distance traveled. They're actually two different things. Here's our starting thinking example. So this question is displacement or change in position the same as distance traveled? Displacement is measured relative to a starting point. And I think that's important to remember, that we always measure our displacement from some known point. So measured from a starting place. Distance traveled is not necessarily, but let's think through this problem. If we consider my typical workday, I leave home around 6 and drive to work, arriving here about 6:30. At 5, I leave work and return home, arriving about 5:30. What is my displacement, or how much does my position change between 6 a.m. and 6 p.m. or 5:30 p.m.? It doesn't change at all. In fact, I started from home, I'm back at home. So in terms of my displacement, or how much I've been moved from home, that displacement or change in position would be 0. My distance traveled, though, is not 0, because clearly I drove to school and then drove back. So when we talk about distance traveled, you're thinking about how far would my car's odometer measure, or how would my legs feel if I had to walk to school. My distance traveled would certainly not be 0. So my distance traveled actually is 2 times however far it is for me to work, and it's about 20 miles. So it's 2 times the distance between me and home, between work and home. And for me, that's 2 times about 20 miles. So my distance traveled is about 40 miles. The point here, though, is that they are not the same. If I think about then what's going on with my velocity over the day, and this is a very rough sketch, but I start out from home, I speed up, I travel for a little while at roughly the same speed, or the same velocity. This velocity is positive because I am increasing my distance from home. I'm traveling towards work. It's a positive direction. And then, I slow down at some point, and I'm at work for a while, so my velocity is 0, probably most of the day. That keeps going on. But then at some point, I leave work and I head back to home. In this case, my velocity is negative because my distance from home is decreasing. I'm going the opposite direction than I was coming here. But again, I speed up. I travel at roughly the same velocity in the opposite direction going home for a period of time, and then I'm back at home. So then the integral from 0 to 11.5, which is the total time my day takes, that integral is going to be 0 because you'll remember the velocity graph. I'm going to redraw it here at the bottom. It looked something like this, and then I was at work for a long time, so my velocity was 0, at least in the car. And then, I came back home, so it's looking like that. So if I calculate the definite integral is going to consider this space as negative, and so I'm going to end up with an overall change in position of 0, an integral value of 0. This, just a reminder of average value. You'll see that 1 over 11.5 and 0 to 11.5 there, so that's average value formula, and that would tell me my average velocity during the day or during the trip. So the integral, because it is positive and then negative, produces a value of 0. The integral is giving me not distance traveled, but displacement or change in position. Depends on whether you've had physics or not, whether you prefer the word displacement or change in position, but either is fine. So this gives me my overall change in position. This second question here gives me the average value, so my average velocity during the trip. I think it would be 0 too, even though I clearly went faster than that and then that same velocity in the negative direction. So now this question, so we found an integral that gives us displacement. I just need to integrate velocity. Sometimes, though, I want to know how far I traveled. That is, how far my car's odometer would measure, or what's the total distance, my total walking or running distance if I were doing that. And in order to do that, I remember that distance can't be negative. And I remember also that I knew from the last chapter something else that could never be negative, which was area. And I remember that the way I corrected the definite integral to handle area was I considered absolute value. I'm going to do the same thing here for distance. So the integral I would use to find my distance traveled, I would find that value by taking the absolute value of velocity. So in that case, I know that speed's the absolute value of velocity, so then I'm really integrating my speed over that interval, which makes some sense in terms of figuring out what my distance traveled would be. So I now have two quantities that are never negative, area and distance. In both of those cases, I'm going to take the absolute value of the function before I integrate it. Here's another example. Notice that in this case I've been given a function for velocity rather than thinking about it graphically. The first question asks me what is the change in position. Change in position can be positive, negative, or 0. So in this case I'm just going to integrate from 0 to 4 v of t dt. I don't have to worry about correcting anything to make sure it's always positive. And so I have that entered into my calculator. Again, I'm just using Math 9 to integrate. And I find that my change in position is negative 1.146. So let's talk about what that means then. Since my change in position is negative, that means that after the 4 seconds, the particle is actually to the left of its starting place. So it's left of where it started. So since its change in position is negative, it's actually 1.146 units to the left of where it started. Question B asked me for the total distance traveled. Total distance traveled, distance I remember must be positive. So I have to fix my definite integral. And so I'm going to fix it by taking the absolute value of velocity. Again, using the calculator, just remembering to put absolute value around my function as entered. It's thinking. My calculator is thinking. It's very difficult to do absolute value types of questions. And I end up with 5.146 units, somethings. When is the particle stopped? That's an old question. 0 equals negative 2 sine 2t. I'm going to leave that one for you to try, and then we'll talk about it in class tomorrow or on your quiz, on your reading quiz. Is the particle speeding up or slowing down at time t is 2? Remember to check speeding up or slowing down. I need to check both velocity and acceleration. The velocity at 2, again, according to my calculator, is 1.514. The acceleration at 2, again using my calculator, is 2.615. And so I think the object is speeding up since both velocity and acceleration are negative. I'm sorry, or positive. A of t have the same sign. Continuing this question, now we've been introduced to a function s of t to represent the position of the particle at time t, and s of 0 is 3. We're being asked to find s of 4. So I need to figure out then something about the position. So I'm going to approach this the same way as I was doing the tub problems where I had an original amount. Here's my original amount. I'm being asked to find some value of that function in the future. And so I know that's the original, wherever I was to start with, plus the change gives me the new total, or in this case, the new position. So originally I was at position 3. I moved over that time interval, and notice that I'm just doing the integral, not the absolute value, because this question is about position, not about distance traveled. I know the answer to this from the work I just did. It was negative 1.145, I think. So 3 minus 1.145 gives me, I am now at 1.885 units, and I'm actually right of where I started. The average velocity, I recognize this as my average rate of change as my average value formula, not average rate of change, because I want to find the average of the function I have, so average value. So I need the 1 over b minus a formula. I'm going from 1 to 4, so 1/4, the integral of 0 to 4 of v of t dt. And I find out using my calculator that's negative 2.285 meters per second. So overall, on average, I'm moving more to the left than to the right.